Let's see the problem greatest common divisor of strings. So in this problem we have given two strings, string 1 and string 2, and we have to find a largest string x such that x divides both string 1 and string 2. So when can we say that any string x divides string s1? Is that if we concatenate string x for one or more than one times, and if we get another string here s1, if we concatenate it here, let's say two times, and we get string s1, then we can say that string x is x divides string 1. Okay, so let's see what is the greatest common divisor in maths. Okay, so let's say we have given two numbers 5 and 10, and we have to find the greatest common divisor of this two. So greatest common divisor is the greatest number which can divide both of this given number perfectly. Okay, and there is no other number greater than that number which can divide both of these number. So it is the greatest common divisor. In this case it would be 5. So we can see here that ABC string divides string 1, which is a concatenation of ABC two times, and here ABC is present only one time. So we can say that the ABC divides string 1 and string 2, and hence this is the GCD. There is no string which is greater than ABC which can divide both of the string. Okay. So from this first example, we can come up with an approach. For example, we can match character by character. In both of the string, we can match character, and when we get the largest string which is matching, and we can return that string. So it does work here, but if we say if we apply that approach in second example, we see that it fails as it is here AB, and it is AB is present here, but on we cannot append the cannot concatenate AB two times. So that approach fails here. So we can improve that approach by introducing two variables, let's say a divisor and empty string. And what we can do is we can append a character to the divisor string, and then we check if this divisor string is a divisor of string 2 and string 1. If it is a divisor, then we store it in GCD, and then again append the second character, and then we continue it until the end. So first we can append a here, the character a, and then we check if the string divisor is a divisor of string 1 and string 2. So it is not, so we do not update the GCD variable, and then again we take the variable b, and we check if the divisor, if it is divisor, so it is, so we update in our variable ab, and after that we take a from here, and if we check it is not a divisor, so we do not update this, and lastly we take the b, and we see that it is not a divisor, so we do not update this, and in the end we return the result. So how can we improve this approach further is that we can start with the greatest string. Since we want the greatest common divisor string, we can start the greatest with the greatest string, which can be a potential greatest common divisor. So as we saw here with the number 5 and 10, the GCD is 5. So there is no number after 5 in this example which can divide 5 and 10. So the smallest number is our uh, possible greatest common divisor. So what we do here is that we take the smallest string, and then we check if it is if it is a divisor of both of the strings. If it is not, then we remove the last character from it, and then again we repeat the process. We repeat it till we find the divisor, and the first divisor in that approach will be our GCD. because there is no string greater than that which is a divisor of both of the string s1 and string s2. Okay. So this is the second approach. For the third approach, let's do little bit of observation. So let's say we have the first string which has length 9 and second string has length of 6. So if we can see here, what is the GCD of 9 and 6? It is 3. So can we say that the GCD string of these two is a substring of length 3? So if we see here, the string which is of length 3, it perfectly divides both of these strings. Okay, let's assume that this is our GCD string. Okay, this is our GCD string. So can there be a GCD string which is greater than this string? Of course not, because it will not divide both of these strings perfectly. Let's say the string of length 4, it will not divide 6 and 9. 5 will not divide this. 6 will not divide this. So yes, we can say that 3 is the maximum length of a string which can be a GCD. So we eliminate all of the strings which has a length greater than 3. And let's see now, can there be a string which is less than 3 and which divides both of these strings perfectly? So less than 3 is 2. So can 2 divide both of these? No. 6, yes, but 9, no. What about 1? So yes, 1 can divide 6 and 9. So let's say there are two candidates, 3 and 1. And if we observe, for 1 to be the divisor of these two strings, for 1 to be the GCD, what the content of the string should be is that all of these strings should be equal. Let's say if this is A, then all of these strings should have A in them. So if all of these strings has A, then only one can divide all of them perfectly. But if all of the all of these characters are A, then of course we can say that the GCD is a, a string which is of length 3. Okay, because 3 is a multiple of 1. So we can definitely say that the GCD of these two numbers is the length of our GCD string. And in which case we can say that the string of length 3 is not the GCD, is when the GCD does not exist at all. Like there is no common string which can divide both of them. Okay, so let's see this with example. So in the first example, we can see that the string of length 3 divides both of the string. But in the second example, we can see that the string of length 3 does not divide the first string because of this D. So if we observe carefully, then we can see that if we repeat the string of length 3 again and again, then we divide both of these strings perfectly. So if we arrange them, let's say this is string 1 and this is string 2, then if we see the string 1 and string 2 will be a will just be a combination of the string which is of length 3. So it does not matter if we put a string 1 first and string 2 later, or string 2 first and string 1 later. Okay, so if we concatenate both of them, but in this case, if we append both of the string, like string 1 and like string 1 and string 2 and string 2 and string 1, then it will not be equal. It will not be equal. Okay, so with based on this condition, we can say that if there exists a GCD, then both of the string, doesn't matter how we concatenate them, string 1 plus string 2 or string 2 plus string 1, both of them will be equal because it will just be a repeating pattern of the GCD string. So let's see the code now. So here we have given two strings, string 1 and string 2, and we have to find the GCD string of these two. So as we saw, if we concatenate string 1 and string 2 or string 2 and string 1, they should be equal. If they are not, then we do not have the GCD string and we return empty string. If we have the GCD string, then we find the GCD of the length of those two strings, and then we return a substring which is of the length GCD. And this is the algorithm which is used to find the GCD. And this is called as Euclidean algorithm. I'll put the link in the description so you can check it.